Hey guys, welcome back to a brand new semester of chemistry. We are starting this semester with chapter 9, which is all about how to name compounds. So we're going to be looking at how to come up with, from NaCl, how to come up with the name sodium chloride. So that's really going to be our focus for this chapter. It's going from the name to the formula, knowing what that means. So when you read your shampoo bottle or the back of your cereal and you see these names, that you know what chemical formula they mean, and then also being able to read a chemical formula and say its name instead of having to say CO2 to be able to say carbon dioxide. So that's really our goal here with this chapter. And there are a whole bunch of rules to it. The good news is that you're distance learning, which means that you're going to be taking notes on how to do these problems, on the rules, and then you'll hopefully, if you've taken good notes, have all of the rules and a bunch of practice problems right there when it's time to take the test, and you'll be able to be really successful on this exam because you'll have all of the tools just right there in front of you. It's more a matter of learning how to use it. So it's kind of like a bunch of life hacks or chemistry hacks to get good at naming chemical molecules. So first, it's important that we recall the fact that sometimes a compound is an ionic compound and other times it is a covalent compound. So I think it bears remembering that ionic compounds are cations and anions that attract each other to make a charge of 0. So that's not a sharing of an electron, that's a complete transfer of electron. It leaves you with the positive cation, because remember cats have pos, and a negative anion, and they attract each other and stick together, and that's an ionic compound. A covalent compound involves the sharing of an electron. So for a covalent compound, what you're going to see is that one element grabs onto the electron of a neighboring element, and that element grabs back, and they end up kind of locked, remember, in a battle to the death. We talked about, like with the Barbies, locked in a battle to the death, trying to win that electron away, but neither one is actually strong enough to do it. So we have ionic compounds and covalent compounds, and they are very, very different from one another. And so because of that, they have totally different rules on how to name them. Both come with a chemical formula. So here is the chemical formula for sodium sulfate, and it has 2 sodiums here, 2 NAs, and it has 1 sulfate polyatomic ion, which we'll learn about polyatomic ions in a little bit, which contains 1 sulfur and 4 oxygens to balance out this charge and to make the ionic compound of sodium sulfate. On the other hand, we can also have covalent compounds. So nitrogen and oxygen are going to form a covalent compound called dinitrogen trioxide. You're going to learn this at the very end of the chapter, how to name covalent compounds, because they're the easier one. They have the less set of rules. And so to name a covalent compound, but it's important to note right here at the beginning that there are 2 different kinds of compounds we could be naming. There's a set of rules if we're doing ionic compounds, and there's a set of rules if we're doing covalent compounds. So whenever you are working on a worksheet or taking a test or working in your notes, it's very important that you identify whether you're doing an ionic or a covalent compound before you get started. And I think I'd like to show you just a quick trick on how to know which one you're looking at. So what I have here is a periodic table, and hopefully you remember this periodic table from last semester. And on the periodic table, there should be a stair-stepping line that starts up here at boron, and it zigzags its way down and across until it reaches the bottom of the table. This right here, this stair-stepping line, separates the metals from the non-metals. So everything that is below and left of the stair-stepping line is a metal, and everything above and to the right is a non-metal. And the reason why this matters is because if you are looking at a compound and one of the elements is a metal and one is a non-metal, then what you're looking at is an ionic compound. And if you're looking at a compound and they're both nonmetals, what you're looking at is a covalent compound. So just to review, we have sodium sulfate up here. Sodium is over here, and sulfur and oxygen are over here. So sodium is a metal, and sulfur and oxygen are nonmetals, so that makes this sodium sulfate an ionic compound. On the other hand, we have nitrogen and oxygen in this compound, and because they are both nonmetals, that's indicating to me that this is a covalent compound. So you can tell whether something's ionic or covalent, one, from the instructions, but as you get further into chemistry, you can tell based on their location of the periodic table. So we're going to begin our conversation about the names of different compounds by starting by naming monatomic ions. So a monatomic ion, mono is one, like the monorail at Disneyland has just one rail around it. Or a monocular is just like a binocular, but it just has one. A monocle is the thing that the Duke wears in Cinderella. You know, when he like plays yo-yo with his little monocle. So mono means one. So a monatomic ion is an ion, charged atom, that is formed from just a single atom. And so the rules for monatomic ions are pretty simple, and we can recognize and remember them by using our periodic table. So it's very important that you are using your periodic table throughout this semester. If you haven't printed one already, you need to print one. If you only have the beautiful one that we made last semester, the one that looks like this, I would actually suggest printing a new one for this semester. You may want to try and write on this one to keep adding to it, but it might get too filled up, and there's no reason you don't want to just print an extra piece of paper. Have a new periodic table to have all of the important chemistry hack information that you need in order to be great at chemistry right there on your new periodic table. So we're going to start by looking at the group numbers and the charges that they make. So anything in group 1 of the periodic table has a 1 plus charge, and remember that's because it wants to lose an electron. Anything in group 2 has a 2 plus charge, they'd like to lose 2 electrons. Group 17 wants to gain electrons. Remember, electrons are negative, and so those are going to have a 1 minus charge. Group 16 wants to gain 2 electrons, so they would have a 2 minus charge, and group 15 would like to gain 3 electrons, so they're going to have a 3 minus charge. So let's look at that on the periodic table. So we are really focusing here on this top part of the periodic table. These are the group numbers up here, and hopefully you remember that from your periodic table project. But we have group 1 here, and group 1 is going to want to have a plus 1, and it wants to have a plus 1 charge because in order to become like a noble gas, it needs to lose 1 electron. For example, sodium here has 11 electrons, 11 protons. And sodium wants to become like a noble gas, and its closest route to doing that is to become like neon. And when it becomes like neon, it now has 10 electrons, which means it lost an electron, so it has a plus 1 charge. We can see the same thing happen with anything in group 2. So everything in group 2 is going to want a plus 2 charge. Again, if we consider magnesium here, magnesium starts with 12, and its closest route to being a noble gas is to go to neon, so magnesium is going to lose 1, 2 electrons to become like neon, and because it lost, it's positive, and because it lost 2, it's positive 2. Okay, now we switch to the other side of the periodic table where we're going to look at group 17. So group 17 over here wants to just gain 1 single electron to become like a noble gas. Fluorine starts with 9, but it wants to be like 10 neon. Chlorine starts with 17, but it wants to be like 18 argon. So these ones are going to gain a single electron, giving them a -1 charge. So that applies to everything in this column. These charges we're putting at the top apply to the whole column down beneath them. In group 16, oxygen wants to gain 2. Selenium wants to gain 2. So these guys are going to be a -2 charge in group 16. And in group 15, they want to gain 3 electrons. Sodium wants to go 7 to 8 to 9 to 10, gains 1, 2, 3. And so this group would like to be -3. While we're over here, it's worth noting, we can talk about aluminum for a second. Aluminum is a metal, meaning that it's going to want to lose electrons. And aluminum is in a particular situation where it wants to lose 1, 2, 3. So aluminum, and actually some of the other elements in this column, like to get a +3 charge. That's not something we would write on there yet because it's not as solid of a rule. It doesn't apply to the whole column, but it is something we can know about aluminum. So when we're thinking about their charges, we're thinking about how many electrons they want to gain and lose. So, little trick question, what's the charge on carbon? What's the charge on silicon? Remember, these are not going to have a charge. They don't want to lose 4 or gain 4 to try to become like a noble gas, and so they are only going to participate in covalent bonds. Carbon and silicon do not form ionic compound. Many of you have asked me actually in the past about the charges of the D block. So the elements that are in the D block and the P block metals. So that's this group right here. So starting from the D block here. Okay, so this is my D block. And then all the way over. And my P block metals, so that comes up here and it's on the inside of this stair-stepping line. This little group here has a lot of variation. So this group that I've kind of quartered off in blue here, these ones can have multiple charges. So things like tin, which is in group 14, or lead, which is also in group 14. So we're just going to look at them really quickly. Tin is right here. Tin and lead are in group 14. They will have either a +2, so they'll lose 2, 1, 2, to kind of empty their P block. Or they'll lose 4, they'll lose these 2, 1, 2, and then these 2 over here, 3, 4, to get very similar to a noble gas configuration. They can do 2 different things to try to get happy, to try to get that happy configuration. And so because of that, when we consider these ions, we have to specify what their charges are. So in the D block, you're going to have to check the charge. So in the D block, charges can vary. So we need to think and consider that.